going to start watching me solve SAT Khan Academy problems live. And so the live stream is beginning. Once again, I'm still trying to sort out this problem. Once again, my camera, I think it's Google Hangouts. There's some malfunction, but it's all good. So we're going to jump right to the screen share and get going now. And we are solving right triangle trigonometry problems. If you haven't seen my music video on SOHCAHTOA, you definitely should. It's on my channel under my music videos playlist. And it's a pretty fun way to remember those guys. All right, let's jump into the screen share. Without further ado, let's take a picture here. And guys, if you're watching on Instagram, again, jump onto my YouTube channel if you actually want to see the problems. If you prefer, I know some people like to just watch me solve them and talk about them, and that is just fine as well. Whatever you like. All right, here we go. Number one. I like trigonometry. It's pretty fun, so let's get into it. So we got a triangle JMN and JKL. They're sort of one's inside the other. The figure at left, and this is a no calculator section problem. So this is pretty interesting, no calculator section on trigonometry. So we're obviously not trying to get an exact number usually. In the figure at the left, JLK and JNM are both right triangles. Which of the following expressions must be equal to the length of line segment KL? And we got one angle of interest here, which is y. Let's think about this for a second. This is pretty tricky. So how would we get KL here? Well, I'm going to look at these different, to be honest, I'm going to look at these different equations because they're unique modifications or they're unique combinations of these trigonometric functions and side ratios. So I'm just going to go in and fill in what all these trigonometric functions represent. So sine of y, again, sine is, let's write SOHCAHTOA up here. SOHCAHTOA. Sine represents opposite, put an OP, over hypotenuse. This is adjacent over hypotenuse. And this is opposite over adjacent. So just remember that. So sine of y, what is opposite y? Oops, let me do it like this. What is opposite y is this whole entire side for the big triangle JMM. And what is adjacent to y is this guy, is blue. And the hypotenuse is always, it doesn't matter what angle you're choosing. Hypotenuse is just this nice green line right here. And so sine of y is opposite, which is JN, over hypotenuse, which is JM, times JK over JL. This is definitely not KL. I mean, I don't think this is KL. I'm assuming it's going to cross off nicely, and we're going to be left with KL somewhere in the mix. And I can't, let's see, but wait, let me just make sure I'm understanding this right. Must be equal to the length of line segment KL. Yeah, I don't see how this makes sense. So I'm going to first still keep filling everything in. So then we have cosine of y over here. Cosine of y, and it's actually the inverse of cosine of y. So cosine is adjacent over hypotenuse. 1 over cosine of y is the opposite. It's hypotenuse over adjacent. So let's go like this. And again, it's y hypotenuse, which is jm, over adjacent, which is mn. Okay, times jk over jl. So I've turned that into sides. Now let's try tangent of y, which is jn. It's opposite over adjacent over mn, right? Opposite jn, mn, times jl. And then last we have 1 over tangent of y. So the flip of this, so it's mn over jn times jl. So now I already got to think about this because it says which one of these now is equal to length KL. And if I were saying, oh, you know what? Y over here, this is also y. Okay, so I'm realizing something. This is also y. And so opposite all of these, I just actually realized something. I should have done this differently. JK, yeah, I chose I chose values here. This is why. This is why. Okay, let me reset this for a second. I was using sides of the big triangle. I should have been using sides of the smaller triangle. Let me first fill you in on what I just realized. These two lines here are parallel. We know that because of these right angles, and I totally missed that at the beginning. That's why this wasn't totally making sense. So it's very important, because these are parallel lines, these guys are corresponding angles, which means this is also y. So I don't just need to be using the big triangle. Since I'm trying to find stuff with the little triangle, I should have been making these ratios with the little triangle. So we're going to use y here. Now I'm going to cut these guys out. And instead of using the big triangle, let's do opposite. Let's use some different colors here. Let's do purple for adjacent. We'll keep red for, actually, no, let's keep it the same. Blue for adjacent, just like we did before. So now we've got KL on top, adjacent. No, I'm sorry, this is sine. Oh boy, I'm having a rough morning. This is opposite over hypotenuse is JL over JK. Ah, look how nice this is now. JL over JK times JK over JL equals 1, right? These guys cross off and these guys cross off. Now this is making way more sense. Goodbye. Goodbye. You see what I did? I'm literally finding the same ratios, but just in the smaller triangle, so we can actually have some things crossing off. So this was 1 over cosine of y, which I said ended up being hypotenuse over adjacent. So hypotenuse is JK over adjacent, which is KL. Oops. KL. And if we got KL here, this doesn't do any good. This is just like JK squared over KL times JL. That's not getting us to KL. What about this guy? Tangent of y is, let's see, and we want the length of KL. What did I say? Tangent of y is opposite over adjacent. So JL over KL, right? Opposite over adjacent. This doesn't work either. This gets JL squared over KL. The last one is tangent of y, 1 over tangent of y, which is the inverse of this guy. This, I think we have a winner here. KL over JL times JL over 1. We can multiply these guys, right? JL over 1. These guys cross off. This is KL. It's a long one. That was complex, but it's D. Let's just make sure we are correct on that. Yes, that is right. That was a doozy. All right, let's keep going. Oh, hey, so Meliari, sorry I didn't see your question. We're doing right triangle trigonometry problems right now. Let's go ahead and jump in here and get another one of these up on the board. Yes, all right, number 2. Whoa, this is crazy. These are intense. So the figure at left has a vertical line of symmetry in the middle. Vertical line of symmetry. So it's this line right here. Maybe I'll draw it. Boom. I'm going to undo that. It just looks messy. The angle BOA, this tiny angle in here is 30 degrees. And the line, this is going to require a calculator, I think. And the line segment BA is 6 inches in length. So this guy is 6 inches. This is so it's a 30, 60, 90, I believe. Let's see if I can do this without making this look crazy. What are we trying to do? How tall is the figure? Oh, okay, I got it. So let's take, this guy is a 60 degrees. This guy, what did it say is 30 BOA? This guy down here is 30 degrees. Okay. And we know that, gosh, this is crazy. Okay, so hold on. Let me wrap my head around this. This guy is our hypotenuse, which means that is 12. I'll get to that in a second. And then the main length we need to find, what is it? We need to find this length. 4 feet. Oh, I see. I see. So you actually don't need trigonometry for this. if I'm getting this correctly. What you need to do, this giant triangle here, let me put this in blue. Man, I feel like these are pretty hard problems, and it's taking me a second to figure them out. I think I figured this one out. So we've got this giant triangle is kind of what we're really assessing. A length of 6, to be honest, if I'm understanding this right, we don't even need that length of 6. We could use it, but we don't need it because we now know that this is a 60, this is a 60-degree angle up here. This is a right angle down here, which means this angle is 30 degrees down here. That means that this triangle right here is a 30, 60, 90. And since we want, how tall is the figure in inches, meaning we want this line segment right here in red. Okay, which is the shortest side of this 30, 60, 90. And the only side we have is this. We have 4 feet, and this is the long leg. Now, if we have a 30, 60, 90, you should check out my music video on 30, 60, 90 triangles. I just made it, special right triangles. Sorry for the plug, but it will teach you this stuff. So if this is 30 degrees, now you know what? Let me take that 4 away. If this is the 30, it looks like a 45, 45, 90, but that's okay. If this is 30, whatever, like this, the smallest side is 1. The hypotenuse is 2, and then this side is square root 3. That's the ratio. And so in this case, since our long leg, or sorry, medium leg is 4 feet, to get the small leg, we take 4 feet and we divide it by square root 3. That's how we go from here to here. If we have this guy, we divide by square root 3 and we get that. So this is just 4 divided by square root 3. And they want this approximately. So all we have to do is say 4 divided by 1.73. Boom, boom. So it's 173 into 400. So it's 2. I'm going to just try and, I could use a calculator. This is a calculator section. But what is it to the nearest inch? Well, let's just see how this pans out. 54, 0, and then that's 3.3. Right? This is just 2. So 2 inches. No, what am I doing? Oh, this is just 2 feet. 2.3 inches. Okay, so I got to turn this into feet. Good thing I read that. So 3, 510, 519. So let's go a little deeper here. And then 21, 0. So this would be 2.31 approximately, let's just say. 2.3. And then we got to multiply this by 12. And it's 6, 4, 0, 3, 2, 6, 7, 2. 20, it should be 27.6, so 28. 28 inches. Again, I would highly recommend using a calculator if you have the option. I like to keep my mental math skills sharp when I'm practicing, but not on the real thing. When I took the real thing last year, I used a calculator. 28, we're right, so there you go. Now, look, they actually used trigonometry in their explanation. You didn't need to, though. They used tangent and all this stuff of 60. Yeah, interesting. So you can use tangent as well if you wanted to, since you do have a calculator and all that, but you didn't need it. All right. Let us move on. It's interesting, like if I were making the SAT in that case, I mean, if I was really trying to make a trigonometry problem, I suppose, not to criticize that question, it was a really good question, but I wouldn't have used 30, 60, 90, because then you don't need trigonometry if you're actually trying to test for that concept, you know? Let's do this one here. What is the measure in degrees of BAC in the figure shown? So we want BAC. We want this angle down here in red. This, I'm pretty sure we need some trigonometry. No, we don't. Again, they're using a 30, 60, 90 again. And I know that because of the ratios. It's like, because I can see that this is a right triangle, and because I know that this is the small leg and the medium leg is 12 root 3, this has to be a 30, 60, 90. I mean, it's just, there's no other way. That's the ratio of the sides. Like, it has to be. So that means the smallest angle over here is 30 degrees, because the smallest leg is opposite 30 and the medium leg is opposite 60. So I know this is 60 degrees for the answer. If you did want to use trigonometry, what you would do is, since we have the two legs and we don't have hypotenuse, you got to use tangent because there's no hypotenuse. So we would take tangent of 60. I'm sorry, tangent of x, excuse me. We don't know it's 60, equals opposite, which is 12 root 3, over adjacent, which is 12. And this simplifies to root 3. So you'd say tangent of x equals root 3, and then you could take arctan of both sides. Arctan is just the inverse of the tangent function. So we'd say arctan of root 3. You take arctan of both sides. This crosses off, and then whatever arctan of root 3 is, would be your answer, and it should be 60. Let's plug it in here. See these special right triangles, man, massive shortcuts if you know them well. My whole course is just so you can memorize it. It's like 45, 45, 90, 1, 1 rooted 2. Those are the ratios. 30, 60, 90, 1 root 3 and 2. It's like that. And if you listen to it a couple times, it'll get stuck in your head. You won't ever forget those ratios. Actually, I think they are actually at the front of the SAT section anyways. So that's nice for the SAT. Question 4. It is given that sine of 27 equals 0.45, cosine of 27 equals 0.89, and tangent of 27 equals whatever. Okay, cool. In the figure at the left, CDA and CBA are right angles. We see that. CD is parallel to AB, right? We kind of can see that. It has to be. And A and CB is parallel to DA, right? All these, it's a rectangle. That's what it's basically saying. Given that the length of AD is 7 and the measure of DAC over here is 27, finally they give us something that's not a special right triangle. Which of the following is closest to the length of AB? Let's just go ahead and fill in all the angles. We know this is 27. This has to be complementary to that, because these guys have to add up to 90 because we got a 90 over here, right? Oh, it's just that is what it is. And these guys are, this is up here an alternate interior angle with 27, so it must be 27 because these two are parallel. This is also 63. And we're trying to find AB. Let me put that in red. We're trying to find that guy. Well, there's a few different ways to do this. I mean, AB is honestly, because this is a rectangle, we've already identified it as a rectangle. We know that it's the same as CD. We could just find CD and we got our answer. Why am I choosing CD? Because they gave us 7 over here, and that's part of this triangle. Like, this is also 7. CB is also 7. It doesn't matter. But I'm just saying, okay, let's switch it to CD. Since it's equal to BA, boom. So now the fun part begins. We got 7. We can kind of choose how we want to do this. We can say, let's actually, no, we need to use tangent. We can't choose because we don't have a hypotenuse value. We have a leg value. So it has to be opposite adjacent. We got to use tangent. Whenever we don't have hypotenuse, tangents are go-to. So I'm going to use tangent of, let's say, 27, because I think they give us, oh, well, they give us all of these, but no, yeah, they only give us 27. So I'm going to say tangent of 27 equals opposite, which is actually what we're trying to find. That's our x, over adjacent, which is 7. Oh, look at this. Again, this is a calculator, but I'm not going to use one. I think I don't need it. When they say tangent 27, that's so nice. They give it to us. Tangent 27 is 0.51 equals x over 7, right? And then all we do is we multiply both sides by 7 because that will give us our answer. You can do this in your head, I think. It's 3.57 equals x. And this should be our answer, which is B. Let's give it a shot. Yes, it works. It is working. And we got the last question of the day. Wow, time has flown. It's already 6 o'clock. I gotta get ready for my morning workout before the day begins. And here we are. Which expression is equivalent to cosine 35 in the right triangle shown to the left? Well, again, I like to always fill in the values. 35 there. This is 55 here, right? There you go. And which one is equivalent to cosine 35? Let's see. Well, what is cosine of 35, first of all? Cosine of 35, in this case, equals xy over hypotenuse. The hypotenuse is always opposite the right angle along the side. So, oh, wait. I'm doing sine. Sorry. Cosine is adjacent over hypotenuse. My bad. So adjacent is whatever is next to this guy, which is xz. And then the hypotenuse, of course, is zy. So this is cosine of 35. Which one of these also gives that one? The same thing. Sine of z would be opposite, which is xy over zy. No, that's not it. Sine of y, which is, I think, going to be our answer, is opposite sine of y is zx, or xz, over hypotenuse, which is zy. So this is our winner. But let's keep going. Cosine of y is adjacent, which is xy, over hypotenuse, which is zy. No. And cosine of x, cosine of x is 1, actually. Cosine of x is 1 because, no, wait, is it 1? I can't remember. This is, no, sine of x would be 1. Cosine of x, gosh, what is it? Cosine of 90, I think is 0. This is weird because it's like adjacent over, I just remember that cosine of 90 is 1. Is 0. I believe from the sine wave. I can't put it into words exactly how that relates to the opposite adjacent thing. You usually don't apply it to a 90-degree angle. But sort of doesn't matter anyways, because we know for sure sine of y is the same as cosine of z, or cosine of 35. All right, let's go with B, and let's give it a shot. And let's see, and it is correct. And that's it. We are done. We are done for this topic. So I'm going to jump back off the screen share. So again, you can't see me. Not sure why. I really got to figure out this issue because periodically the camera in Google Hangouts doesn't work. But that's all good. We still got through the problems. I hope that was helpful. Please comment if you have questions, additional questions, and also like this video. And lastly, subscribe to see more excellent SAT Khan Academy videos. More importantly, see my other videos too. I have my music videos that come out about once a month on different math concepts. That's all for today. I hope you guys have an amazing day. Take it easy.